Now in this video, we are trying to understand a very important aspect of vector applications, force. Most of the problems which we have in this application will be dealing with the state of equilibrium, right? So we will understand what the state of equilibrium is and how to achieve it. So we need to understand few terms. One of them is equilibrant of several forces. As you know, normally at any object there are so many forces acting together. Now it's very difficult to individually look into these forces and find its effect. So what we do is we try to find the net effect of all the forces. Now net effect of all the forces will result into doing something. Now if you want that object not to move or not to do anything, then in that case a force equal and opposite will be applied so that everything stays where it is. And we call this as a state of equilibrium. And this force which is being applied, which is directly opposite and equal to the magnitude of resultant force, is called equilibrant force. So let's try to see what the definition is, and then we have two examples here for you to try. So equilibrant of several forces. Equilibrant is the force which maintains the object in a state of equilibrium. It is a single force that is equal and opposite to the resultant. The state of equilibrium is defined as a state in which the net force acting on an object is zero. So this is the concept which we need to understand now. So let's take with an example. Let us say we have a force in this direction and we have another force in, let me take another ink, let's say in this direction. Now when these two forces are acting at a point, then you can find a resultant of these forces by vector addition of forces, correct? Force is a vector. It has magnitude and direction. So we'll place this so that the head of this force is right there. So the tail of this force is on the head of the previous one, right? So when you put them like this, then you can find the resultant of the force. So the resultant in this case will be from tail of the first to the head of the last, right? There could be many forces like this, and that we call as the resultant force. Now the effect of these two forces is to move this object in that direction, since that is the resultant or the net force. Now if I apply another force which is equal and opposite to this force, so that means I am applying a force here which is equal and opposite, so direction is directly opposite and the length is same, right? That is my equal and opposite force which is being applied at this particular point. Let us say this point is A. Then what will be the effect? This point will stay where it is. We call this as a state of equilibrium, and this force is the equilibrant force. So let me call as Fe. So Fe is the equilibrant force which keeps the whole system in a state of equilibrium. That means no movement, right? So net force acting on this is now zero. The effect of these two forces was Fr, and we added a equilibrate force which is equal and opposite to Fr. Therefore the net is zero, right? So that is the philosophy here. So we try to find the net force, and then we say, well, we try to find the resultant force of the given vectors, and then we say, well, if we want to keep the system in rest, then we need to apply a force which is equal and opposite to this resultant force, and we call that force as equilibrate force. Now on the other hand, sometimes when you see, well, there are so many forces acting on a body, but the body is in a state of rest. For example, let's take an example of an inclined plane. Now in an inclined plane, if I have a body somewhere here, the body has weight, and because of the weight it tends to move. But you will find sometimes it just stays there wherever it is for a particular angle theta, right? So that means it is in a state of rest. But mind it, it is in a state of rest, but there are so many forces acting on it. The force of gravity, the weight, and this weight can be split into other forces, right? Now, but still it is in a state of rest. Why is it so? So that is what it is. So that means there must be some force acting against these forces which are trying to pull it down. That force we know is the force of friction, right? Now in this case, we can find the force of friction which is keeping the body at one place, not letting it move or slide along the plane, by finding out what is the component of this weight along the inclined path, because it has to be equal and opposite. Do you understand? Similarly, we have a normal force here, which should be equal to the component which is along that direction, normal to the inclination, right? So these are the type of problems which we can solve using equilibrium forces, right? And many more. So I have two examples here for you. Answers are given. I would like you to answer these questions. They should not be very difficult since you have done vectors and you know how to resolve vectors. So it is an application of vectors. Apply your knowledge and see if you can find it. Then we have the solutions of these problems in coming videos. The question here is, determine the equilibrium of two forces, 40 Newton and 20 Newton, acting at an angle of 45 degrees. So well, you can say it's like this, where one force is 40, the other is 20, and they're acting at an angle of 45 degrees. So this angle is 45 degrees, right? So you need to find the equilibrium of the two forces. That means in this diagram, find the resultant. You can use cosine law to find the resultant, right? So the magnitude of equilibrium force will be same as the resultant, but the direction will be opposite. So try to find this angle from one force, right? So that should give you the answer, right? Now I prefer you should write, depends how you write the angle. So that is how you should be doing it. Question 2 is, a 20 kilogram object is at rest on an inclined plane that makes an angle of 25 degrees. So theta is given as 25 degrees to you with the horizontal. Find the minimal magnitude of frictional force. Now if the object is not moving, then the component along the inclined path should be same as the frictional force. So that component, when equated to frictional force, will give you the answer, right? So the answers are given to you. Try to solve these problems and understand the concept of equilibrium forces. I hope that helps. Thank you.